Hello students, once again welcome to Bholanathacademy. In this video students, we are going to see the physical properties of aldehyde, ketone and carboxylic acid. Physical properties students, first we will see the nature of intermolecular forces between two molecules of aldehyde, between two molecules of ketones and between two molecules of carboxylic acid. Which type of nature is occurred? Which type of forces are there present in between two molecules? So we are going to see the nature of intermolecular forces. Now second physical state students, we are going to see the physical property, that is physical state. Second physical property, we are going to see the physical state. State means whether they are present in solid, liquid or gases. That is we call as what? State. And we will see the boiling points of aldehyde and ketones. Okay students, we are going to see the boiling point. At what temperature, if they are solid and liquid, they will boil. That we are going to see, that is physical property. Students, mind well, we are going to see the physical property. Now third is we are going to see the solubility. Ability to dissolve is called as what? Solubility of aldehydes and ketone also we are going to see. Now students, which factor which affect the solubility of aldehyde and ketones? Now fourth property students, in carboxylic acid students, we will see the physical state of carboxylic acid, boiling point of carboxylic acid and the solubility. All three physical property of carboxylic acid, that is acid, that we are going to see. Okay students, so these are the physical property in this video students we are going to see. So students, first we are going to see in detail about the nature of intermolecular forces. Now students, which forces are responsible between two molecules to hold the aldehyde and ketones? So that we are going to see students, when you see the molecule of aldehyde and ketone students, both are containing carbonyl. This is carbonyl group students. Now here students, the carbonyl bond, this carbon or oxygen we call as carbonyl bond in aldehyde as well as in ketones. This carbonyl bond is present in aldehyde and ketones, is a polar covalent bond. Always mind well students, in aldehyde and ketone carbonyl bond is always polar covalent bond. There is a polarity is there students in aldehyde. If this carbonyl is present in aldehyde and ketones, they are polar covalent bond. These compounds contain dipole force of attraction. So understand students, so which type of forces students? Dipole forces of attractions are there between the molecules of aldehyde and ketones. Now students, you know students, carbonyl, there is a carbon and oxygen double bond is there students. Oxygen is more electronegativity, that we are showing with delta negative charge, and here students, carbon of the carbonyl will be always we are showing with delta positive. Delta stands for partial negative and delta plus stands for partial positive charge. That means here students, electron cloud, all the electron cloud is shifted towards the oxygen of the carbonyl. Okay students, here you will find more electron clouds, more electrons are present at the oxygen side. Now students, when we see another molecule of aldehyde and ketones students, because of dipole moment, because of this moment students, they will rotate. Now carbon will go in upper side, okay students, and oxygen will come downside. Okay students, here will be delta negative charge and this will be delta positive. Understanding? So this way students, because of dipole forces of attraction, there is attraction is there students, because these are opposite charges. This is partial negative and this is partial, so there will be attraction. Understanding students? Here also students, carbon of the carbon will have partial positive charge and oxygen of the carbonyl will have partial negative charge. Because of that students, there is an attraction. So there is an intermolecular force of attraction, so that is nothing but dipole force of attraction. Understanding students? Now students, when you come in carboxylic acid students, carboxylic acid have strongest intermolecular force of attraction due to hydrogen bonding of hydroxyl group. See students, in carboxylic acid students, when you see students, one example I am giving you students, acetic acid, CS3 students, acetic acid, here CO and carbon is there students, and here it is what? OH, CS3COH. In short we are saying CS3COOH. This is the one acetic acid structure I have shown you students, carbon is tetravalent. Now students, another molecules students, here oxygen, here oxygen will be delta negative charge and the hydrogen of this hydroxyl will be delta positive. Now students, when you are seeing second molecules of acetic acid, oxygen, here I am showing this will be delta negative charge, and students, here hydrogen of this hydroxyl will be delta positive. So there will be the attraction students. This attraction is because of this hydrogen. So due to the hydrogen bondings students, these molecules have come close to each other. That means it is having strongest intermolecular force of attraction. Understanding students? Strongest molecular force of attraction as compared to aldehyde and ketone. Understanding students? So this I have shown students how the one molecule of acetic acid attract to another molecules. So here students, it will be having strongest intermolecular force of attraction as compared to aldehyde and ketone. Now students, this is all about the nature of intermolecular force of aldehyde, ketones and carboxylic acid. Now we are going to see the physical state, students, physical state and boiling point of aldehydes and ketone. Okay students, now students, methanol, that we are also called as formaldehyde, is a gas at room temperature. Now students, the first carbon containing aldehyde is methanol, we also call as formaldehyde, is gas at room temperature, and it is having irritating odor also. Now students, here we are talking about physical states. So physical state, students, for methanol will be always in gaseous state at room temperature. Ethanol, acetaldehyde, ethanol, this is acetaldehyde, students, it is a liquid. It is what? Liquid and colorless liquid. Which type of liquid? Colorless liquid. So this is all about the physical state, students. Here also, students, this, when you are talking about ketone, students, acetone is liquid at room temperature. Now in ketone, students, example, this is liquid at room temperature. That means only the methanol, which are gases, other what they are present in liquid state. So acetone, which is ketone, students, is liquid at room temperature. Okay students, now here students, I have shown the boiling point of aldehyde as well as what? Ketones. Aldehyde as well as ketone, students, boiling point. When you see the boiling point, students, methanol is 252 Kelvin, ethanol is 294 Kelvin, propanol is 319 Kelvin, butanol, this is the structure of butanol, students, 348 Kelvin, pentanol is what? 376. Now when you see the number, students, 352, 294, 319, it is go on increasing. It is as the carbon of the aldehyde increases from top to bottom, students, the boiling point is also increases. That means boiling point increases as the molecular mass increases. Understanding, students? Same way, students, when it comes to the ketone, students, in ketone also, students, propanol is 329 Kelvin. When you are talking about butane 2ON, it is 352 Kelvin. Pentane 2ON is 375 Kelvin. Now when you see the number, students, 329 Kelvin, 352 Kelvin and 3, see the number is increasing. So also you can say, students, in ketone, as the molecular mass increases, as the number of carbon increases, boiling point is also increases. Okay students, now when you see, students, in propanol, here students, both are having what? 300, both are propanol and this is propanol. Okay students, molecular mass mostly similar because of the carbonyl is present between the molecule, it is having higher boiling point as compared to here the carbonyl is as at the terminal, it is having 319 Kelvin. So this way, students, ketone is having higher boiling point as compared to aldehyde. Now students, we are going to see solubility, ability to dissolve, students, of aldehyde and ketone, that we are going to see, that is solubility of aldehyde and ketones. Now when you are talking about the solubility, students, lower aldehyde, that means methanol, ethanol, propanol, and ketones are water soluble due to hydrogen bonding. Ketone, that is acetones, are water soluble due to the hydrogen bonding. Now as the molecular mass increases, students, please pay attention, molecular mass increases, you cannot find hydrogen bonding. There is very difficult to find and the water solubility decreases. This is very important, students, very important. And because of the molecular masses, solubility decreases. Just as it is increases, the solubility we are showing with capital S is decreases. It is decreases as the molecular mass increases. So students, the solubility, that is capital S, of aldehyde and ketone, students, both are containing carbonyl group. Here students, solubilities we are going to dissolve in water. Okay students, that formula is H2O. Now students, solubility of aldehyde and ketones. Now both aldehyde and ketones is containing carbonyl, carbon and oxygen bond, carbon oxygen double bond. Now here students, depending upon alkyl and hydrogen, this is called as aldehyde. If both are containing alkyl group, we call as ketone. Now students, now we are going to draw the water molecules. Water having oxygen and hydrogen bond, students. This hydrogen of water is having partial positive charge and this is partial negative charge. Here also this hydrogen will have partial positive and this oxygen is partial negative. Now this is water molecule, students. Now here also, students, this is aldehyde. This is aldehyde, students, RCHO, or you can say ketone. Okay students, so carbonyl of aldehyde and ketone, students, this oxygen will have partial negative charge and carbon of the carbonyl of aldehyde and ketone will having partial positive charge. Okay students, there is a attraction because of partial negative and partial positive, unlike charge attract each other. Because of this, students, this carbonyl will attract to the water molecules. Understanding, there is an attraction of that means there is a presence of hydrogen bonding. There is a one hydrogen bonding is there. There is one hydrogen bonding. There is a one hydrogen bonding are present between oxygen, one molecule of water and one molecule of aldehyde ketones. So because of this, students, this hydrogen bonding, there is a attraction and it totally depends upon the solubility. The solubility is dependent on this hydrogen bonding. Lower aldehyde and ketones are water soluble due to hydrogen bonding. So this is the hydrogen bonding, students. As the molecular mass increases, which cannot form hydrogen bonding, and the water solubility decreases. As the molecular mass increases, students of aldehyde and ketones, molecular mass increases, this hydrogen bonding decreases. Otherwise, therefore you can say solubility decreases. The hydrogen bonding will decreases. That is why solubility decreases. Understanding, students? So molecular mass increases. As the molecular mass increases, which cannot form hydrogen bond, and the water solubility decreases. So this is all about aldehyde and ketones, solubility of aldehyde and ketones, physical state, boiling point, and solubility of carboxylic acid. Physical state, students, lower aliphatic carboxylic. Only the carboxylic acid we are going to see, students, when we are talking about physical state. Lower aliphatic carboxylic acid containing less number of carbon, first carbon, second carbon. So lower aliphatic carboxylic acid up to 9, carbon number 1 to carbon number 9 carbon atoms, they are colorless liquid. They are what? Liquid, colorless liquid. Now higher carboxylic acid are wax-like solids. Okay, students, more than 9 students carboxylic acid, they are what? Solid state. Boiling point of carboxylic acid have higher boiling. When you are talking about now, students, this I have shown. Now boiling point, students, we are going to see of carboxylic acid have higher than those are boiling point of alkanes, ethers, alcohols, and aldehyde and ketones. Because of what? Because of hydrogen bonding. So boiling point is always higher than these alkanes, ethers, alcohols, aldehyde, and ketones. Now, students, we are talking about solubility, that we are showing with capital S. Solubility of carboxylic acid in water decreases with increase in molar. That I have already told. Solubility is what? Decreases. Solubility of carboxylic acid in water decreases with increase in molecular mass. Why, students? Because of the increase in hydrophobic, that is water heating, and interaction of hydrogen carbon part. Okay, students. So due to the increase in hydrophobic, that is water heating, interaction of hydrocarbon part. Okay, students, as a hydrocarbon, that is CS3 and CS2, as this increases, this is called a hydrocarbon part. As increases, the water heating properties is increased. Understanding, students? It is increased as these groups are increasing. Solubility of carboxylic acid in water decrease with increase in molecular mass. Why molecular mass increases, students? Because of increase in hydrophobic, that is water heating, hydrocarbon part, that is methyl and methylene. Okay, students? So this is all about the physical state, boiling point, and solubility of carboxylic acid. In examination, sometimes they are asking. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.